Okay, welcome back. In this video we're going to look at the specific heat capacity of water and use it to find out how much energy is required to heat water, in this case, from one temperature to another. But it can apply generically to any substance. First of all, we need to mention that all matter heats up and cools down at a different rate. So some matter can take a lot of heat and can store a lot of heat and then release that heat slowly. It usually takes a long time to heat something like that up, but then it takes a long time to cool down. It releases its heat slow. A lot of other materials will heat up very quickly. Say iron or steel can heat up very, very quickly, but then also get cold very quickly. And so those two materials will have a different specific heat. So the heat has everything to do with what how much heat or how much energy it takes to change temperature. So let's do first of all the definition, and this is the definition of heat capacity. Heat capacity is shown with a capital C, and it's the amount of energy absorbed or released per unit of the substance temperature change. So you have a certain amount of material and it takes so many joules to heat it up so many degrees. That's its heat capacity. The formula for this is the heat capacity C is equal to Q over the change in temperature. So it's a ratio between the energy used in joules and the change in temperature that you get from that amount of energy. So from here we can take this and switch it around and solve for Q, because a lot of times we're interested in the heat of something, how heat is released or heat is absorbed. So if we were talking about an exothermic reaction, how heat is released, or endothermic, or whether something heats up or cools down, usually it's heat that we're interested in. So we'll see that Q is equal to the heat capacity, C, times the change in temperature. Now, the heat capacity, remember, is any amount. You don't have to know a specific weight. It's just the generic ratio of that material. If you're talking about a specific mass of a material or a substance, then you would use the specific heat capacity. It's designated as a lowercase c, and the specific heat capacity is very similar to the heat capacity. It's just divided by the mass, so it's per unit of mass. So we have the heat capacity C divided by whatever mass of the substance you're talking about, and so lowercase c is the specific heat, and so the heat capacity is equal to the specific heat times the mass that you're talking about. Here's an example. How much heat does it require to raise the temperature of 250 mils of water from room temperature, 22 Celsius, to boiling, 100 Celsius? So the first thing is you need to know the heat capacity of water, because this is the material that we're studying, and experimentally it's been shown that it's 4.184 joules per gram Celsius. The other thing that you need to know is that the density of water is 1 gram per milliliter. So if you have 200 milliliters of water, it's going to weigh 250 grams. Really simple for that to figure it out that way. So before I can do anything, I need to know what my change in temperature is. So 100, that's my final temperature, minus 22, it gives you 78 degrees of difference. So putting all this together, we are going to use the formula Q equals Cm delta T, and this is specific heat times the mass times the change in temperature. So Q is going to equal 4.84 joules per gram Celsius times the 250 grams of what the water weighs times the change in temperature from 22 to 100, so that's 78. When you do that product, you get with 82,000 joules. It's easier to express that in kilojoules, so it's 82 kilojoules. Hope this helped you.